All right. Scientific notation is all about pointing out exactly what's significant and what isn't. All right. So we're going to represent all these numbers in a different form that shows us exactly what's significant. All right. So we found out that there's only one significant figure in this number, right? And it was this 1. All right. So the way we write scientific notation is we take the significant digits and we multiply them by however many times we had to move the decimal to get it over to here. So we had to move it 1, 2, 3, 4, 5, 6 spaces. All right. So 1 times 10 to the 6th is how we would write this in scientific notation. Now, what is this pointing out? And I'm going to change this color here if I could. Or maybe I'll just change this one. Okay, I'm going to make this red. All right. And that's showing us this is the only significant digit. All right. So when I look at this, it's easy for me to tell there's only one significant digit there. Whereas if I look over here, I have to apply all these rules. Okay. So let's apply the same thing over here. All right. Here, I'm going to move the decimal 1, 2, 3 spaces. All right. So I'm going to have 1 times 10 to the 3. Okay. Now, just I'm not sure if you know how these powers work, but just know that this number here, 10 to the whatever this number is how many times you had to move the decimal to get it over here. Okay, so we moved it 3 decimal places. That's where this power of 3 comes from. Okay, and again, I'm going to highlight our significant figures. All right, so again, just by looking at the scientific notation, I can tell right away we only have one significant figure. Didn't have to look and apply my rules and realize that these zeros didn't count. Okay. All right, so next example. All right, here. Now, another thing that I want to point out is when we move this decimal over, I'm not just moving it to the first non-zero, okay? I'm moving it all the way over so that I only have one digit to the left of the decimal, okay? So I'm never going to have 10 point something, all right? I'm not going to have something like this, 101 times 10 to the something, okay? I only want to have one digit here, and everything else is going to be after the decimal. So I'm going to have 1.01. Okay, I'm only going to put in the significant figures here. These are the only significant digits. All right, so those are the only ones that go into my number. All right, and then 10 times however many spaces I had to move over. Okay, so my decimal was here, or would have been here. So 1, 2, 3, 4, 5. Okay, so to get the decimal to here, I need to move it 5 spaces. So times 10 to the 5. All right, again, I'm going to highlight the part that's significant. All right, again, scientific notation. Now I can look at this scientific notation and see 1, 2, 3 significant figures. Easy, okay? So you can see how this method of writing a number automatically points out to us what's significant and what isn't. All right, so let's go ahead and fill in the rest of these quickly. All right, here all of these were significant. So now I've got to write 1.00001, okay? And I'm just going to bring it down to the next line here, times 10 to, let's see how many times I have to move it over. 1, 2, 3, 4, 5 again. Okay. Now here, point out my significant digits again. All right. And you can see it's easy. I can look over here and see 1, 2, 3, 4, 5, 6 significant digits. Okay, I didn't have to apply any strange rules or, figure out what was going on over here. So scientific notation, very convenient for us. All right. Now, I'm going to let you fill in some of these on your own, but I'm going to pick out a couple of examples. Notice that this decimal doesn't really affect scientific notation, okay? So here, all this is telling me here was that because of this decimal, I can count all these numbers. So I had 2 significant digits. So when I write my notation, I'm going to write 1.0, okay? Because both of these are significant, so they're going to get to show up here. All right, 1.0 times 10, and I have to move the decimal 2 spaces in this case, okay? Or I'm sorry, 1 space. So 1 to get it there, all right? Same deal. I highlight this up, and I can see right away from my scientific notation that I only had 2 significant figures, okay? So this goes on and on and on. And as you can see, the advantage here is that scientific notation points out unambiguously what digits are significant. Okay. I'll just do one of these examples over here. Again, this is less than 0, okay? But so what we're going to do is we're going to count this way to find our first where we want to move that decimal point. So here we're going to move it 1, 2, 3, 4, 5 spaces. Okay, so we're going to have 1.0, right? Because both of these are significant, these two. All right, so I need to include that 0.0 there. All right, times 10 to, how many spaces did I move it? 1, 2, 3, 4, 5. All right, but since I move it to the right, it's minus 5. Okay, here's my significant digits. Again, they line up. And what's nice about this, again, is I didn't have to remember that all these zeros didn't count. Okay, I can just look at this notation and know right away I've only got 2 significant figures. All right, so I'll let you guys go ahead and fill in the rest of this. But that's really all there is to counting significant figures. All right, break it down. Is the number greater than or equal to 1? You sort of do it this way. All right, and you are concerned about where that decimal is, if we have one or we don't, right? Because we do different rules. All right, or is it less than 1? All right, and then we apply these rules over here. So practice these a little bit. Hopefully this has made it a lot less mysterious to you, and good luck. Thanks for watching Omaha Chemistry Tutors video tutorials at getsupersmart.com. Tell your friends.